Okay, so taking a look at numbers 31 and 33 in section 3.7. So for 31, it says a right circular cylinder is to be designed to hold 22 cubic inches of a soft drink. And they tell us this is approximately 12 fluid ounces. You do not ever have to make these tables. You don't have to do part B. We're going to skim down and see what it is they really want us to find. It says find dimensions that will yield the minimum surface area. That's our goal right there, okay? To find the dimensions that will give us the minimum surface area, because that's going to minimize our cost and our supplies, because we're going to have the smallest surface area with the required volume, okay? So going back up here again, right circular cylinder, 22 cubic inches of soft drink. All right, so that means our volume then, volume is going to have to be 22. So we have to think, what's the volume of the cylinder? What is it? Pi r squared h is going to have to be 22. If you're okay sticking with the r's and h's, you can. A lot of people like to switch it so that x equals r and y equals h. Just, we're more used to working with these. If you choose to do that, then you're going to have pi x squared y equals 22. We are trying to minimize surface area. The surface area formula, we just talked about that. We need the area of the bases, which is pi r squared. We have two of them. Plus, we have to do the circumference of the base times the height. Okay? Well, what that's going to give us then, if we change it to x's and y's, is this. I have to take the derivative. I can't if I have a y. So I'm going to go back here and find out what y is. Now I'm going to substitute it in. And so now I'm going to have to take the derivative. I want to distribute this out first. That's going to give me 44. The pi's would cancel, 44 over x. Simplifying that, this is really going to be 2 pi x squared plus 44 x to the negative 1. That's the same thing. Take the derivative now. So that's going to be 2 pi times 2 is 4 pi x plus negative 44 x to the negative 2. I have to set that equal to 0. I'm going to take this over. I'm going to cross multiply. Okay, so then to finish this then, I'm going to have to divide by 4 pi. So if I'm doing 44 over 4 pi, that would just be 11 over pi. And I'm going to have to take the cube root. So that's the exact answer for my radius. If I wanted to double check, I could take the second derivative, plug it in, make sure that it is going to be a minimum. It's going to be a minimum though. So now I want to find the dimensions, is it? Yes. So I'm going to find this decimal approximation. Know how to use your calculator. With the newer calculators, I can just do math, cube root. I can put in a fraction by doing alpha y equals. And I can do 11 over pi. And that's going to give me this. So that's going to be my approximate answer for my radius. Okay? If you have an older calculator, you have to be careful here, guys. You got to put in parentheses. Well, actually, you don't really need parentheses. I was thinking if we had like a 2 pi or a 3 pi, you'd have to put parentheses around that, but you don't have to in this case. So we have x is this. If I want to find y, I just go back up and I find y. Here's y. Here's what I was getting to. Now watch this, guys, how you can put this in. It's going to be 22 divided by parentheses pi. I need my last answer, so I'm going to go up here and get it, squared. And it's 3.04. Okay? If you don't have that feature where you can go up and get that other answer, you can just plug it in, 22 divided by parentheses pi times, and you can do just second answer to bring up the last answer you had, and you can put it in that way, or you can even round it if you have to. But the more that you round, the further off your answer is going to be. I didn't square it. You get the idea. Okay? All right, let's take a look at 33. Somebody asked for that one. Okay, 33, this is about the package that we're going to send. So it says a rectangular package is to be sent by a postal service, and it can have a maximum combined length and girth. The girth is just the perimeter of this cross section here, and that can be a maximum of 108. Find the dimensions of the package of maximum volume that can be sent. All right, so we know that this perimeter plus this has to equal 108. What's that going to be? This perimeter all the way around here. What is it? This is x, 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 x. So what is it? 4x plus y can equal 108. So that's our primary equation. Sorry. We are trying to maximize the volume. Here's our volume. Area of the base times the height. What am I going to do? Find y. So y is going to have to be 108 minus 4x. Substitute it in. So then v is going to be 108x squared minus 4x cubed. Take the derivative, that's 216x minus 12x squared. Set it equal to 0, so then I can bring this over. Let's just keep it like this. 0 equals, I'm going to factor out a 12x. I'm left with 18 minus x. So I have two critical numbers. One is 0 and one is 18. Well, what's 0 going to do to our volume? Make it 0. So I know that's going to give me the minimum. So I certainly don't want to use that. 18 is going to have to be the answer. I could do the second derivative test if necessary. So I know then that x is going to have to be 18. And y is going to have to be 108 minus 4 times 18. And what is that? 72, 108 minus 72, 36, right? So there's our dimensions. Okay? Got to work through these, Andy.
So every time if you see a word girth, it's just right in perimeter, not right in surface area.
No. That means distance around something. Yep. All right. We'll stop there.